All right, picture this. You're in line at a bar, and the bouncer says, hey, the cover of the night is $6. Like, $6? Why the hell is it $6? It's stupid, but that's not the point. What the point is you have a wallet full of cash, a $10 bill, a $1 bill, a $20 bill, a $5 bill. Can you come up with the 2 bills to pay the cover before you get booted to the end of the line? That's essentially the problem here. This is essentially LeetCode to sum, and today I'm going to teach you how to solve this problem. Let's go. So the boring way that LeetCode describes this problem is given an array of integers nubs, an integer target, return the indices of the 2 numbers and right after the target. That's boring. All right, the fun version of this problem is the bouncer needs $6. Can you come up with the 2 bills needed to pay that? LeetCode, if you need to rewrite these problems, hit me up. I'm a genius, clearly. So we see we got the bouncer with this buck tooth yelling you for $6. And you got a wallet right here with $10, $1, $20, and $5. And looking at this problem, you might immediately think, oh, the $6, it's easy. I got the $1 here, the $5 here. So the answer is clearly 1 and 3. And you just return that. Easy, right? How would we code this? So a lot of people might think of a brute force solution. Like, oh, let's just go one at a time through the elements of the array, and we'll calculate the pairs. If that's the answer, awesome. Otherwise, we'll go on to the next element, calculate that pair. If that's it, awesome. If not, you do that. So on and so forth until the bar eventually closes and it's 3 a.m. and you need an Uber home. A lot of people like to call this solution the brute force solution. Okay, but I don't think that's a good name for it. I like to call it the drunk dude, because if you try to do this solution, you're going to look like an idiot. Respectfully. Like, I'm just saying, if you're in a technical interview and you go with the brute force drunk dude solution, I don't know who's going to get that job, but I tell you what, it ain't going to be you. All right, that's a fact right there. It ain't going to be you. And if you were in this situation in real life, if you were in real life waiting to get into a bar and the bouncer's waiting and you're slowly checking each possible pair for the sum of the cash, everybody's going to be looking at you in line like this. Like this. That's so embarrassing. Don't do that. Don't be the drunk dude, okay? Nobody likes the drunk dude. But let me tell you, mathematically speaking, why this solution is buns, okay? Because if you went through a whole array of length n and you checked every single pairs, you'd be going through the array of length n times, okay, for each pair. Do you know what n times n is? Buddy, that is n squared. You really want to give an n squared solution a big O time complexity? No. You are cooked if you do that. You are absolutely cooked. Unless there's absolutely no other possible solution, which guess what? Brute force almost never is. Almost never is. I will show you how cooked you will be. I will show you right here. This is literally going to be you. I don't want that for you. I'm a nice guy. This is a safe space. But you will be cooked. Candidly. So what if instead of flipping through your entire wallet like an absolute jabroni, you can just remember what you have and what you need? Like, what if you were iterating through your wallet and you saw this $1 bill and you were like, oh, all I need is a 5. And then once you get to the 5, bingo, you're in. And then you won't have girls looking at you like this. In fact, they'll probably find you in the bar and be like, wow, that was really cool what you did out there. You must be really good at LeetCode too. So I'm going to be like, yeah, I am. What's your number? And I digress. I just get a little excited. But still, like that sounds like a good idea, if you ask me. So how can we go through this array and be able to instantaneously remember what we have? Just like your brain would instantly remember in that moment in line. So what we're going to do is we're going to create an empty dictionary, right? Full of key value pairs. That is a 3. That is not a bracket. Holy. And all this dictionary is going to hold is key value pairs, with the key being the number of a given. What the hell is given? Of a given index, and the value being the actual index. I'll tell you why in just a second. Can you relax? I'll get to it. Jesus. Let's just run through the approach of the actual solution here and just draw it out so you can visualize it and see what's going on. So what we're going to do is we're going to iterate through the entire array one element at a time, taking note of the element as well as the element's index. So let's start at 10. Index 0, our very first element. What we're going to do is we're going to calculate the complement between, which is essentially just the difference between the element and the target. So we're going to do 6 minus 10 equals -4. What we're going to do from here is we're going to check, is this complement, does that exist in our dictionary? Because if so, then we just return the index of the current element we're at and the index of where 4 is at. And doing this is really easy with hash maps and dictionaries because finding an element is always done in constant time. Big O of 1. That is so ugly. Let me redo that. Big O of 1, constant time, which is amazing. But that's essentially how fast it is to remember an element you already saw. That's why using a dictionary is a great analogy to using your brain and just remembering, because you instantly know if you already saw something. If we get to 1, then we can remember, okay, all we need is 5 to get to 6. And once we get to 5, we already know that we just saw 1. So these two would be the answer, or the indexes of them. Indices of them would rather be the solution to our problem. Okay, so we established that currently we're at 10. We calculated the complement. 6 minus 10 equals -4. -4 is not in the dictionary, so we're going to go ahead and put the value of the current element with its index as its value. So 10 and 0. Now, iterating to the next element, 1, we can calculate the complement again. So 6 minus 1 equals 5. Is 5 in our dictionary? No. So what we're going to do, again, put the value that we're currently at, 1, as the key value pair in our dictionary. Now we go to the next element, 20. 6 minus 20 is -14. Is -14 in our dictionary? Nope. So we're going to put 20 as the key and index 2 as the value. Finally, we reach element 5. Calculate the complement of that. 6 minus 5 equals 1. Is 1 in our dictionary? Yes. We can clearly see with a constant search of a hash map that 1 is in our dictionary. So therefore, we can return that index, which is the value of dictionary 1. Let me rephrase that. I apologize. This is my first time making a LeetCode video, so it's relatively new to me actually speaking this out. So we know that 1 exists in our dictionary. We've seen it before, and its respective value is 1, which is an index. So we put 1 into our result answer, and then we take the index of the current value, 5, that we're at, which we know is 3. So our final answer to return will be 1 and 3, which again, if we look at this wallet array in plain sight, I mean, we established this at the beginning. We clearly see that there's a $1 bill here, a $5 bill here. Those are the answers. Like 1 plus 5 equals 6. We know that that index 1 and 3 is going to let us into the bar, and people won't be looking at us like a drunk idiot. So now that that's squared away, let's put this into some actual code. So first things first, let's instantiate that dictionary that lets us see where we've been. Let's call it brain. No, let's not do that. Again, guys, this is my first time making a video like this. In the scenario of an interview, you want to name your variables appropriately. Anything that you make, you want to name it well so it makes sense, because we want to make clear, concise code for the interviewer or anyone else to understand. So let's call this scene, because the dictionary is going to act as a place for us to remember if we've seen a value yet or not. Now we're going to loop through our array. We're going to say for I num in enumerate nums. If you guys can tell, I'm coding this in Python, which is my preference, my language preference. Using enumerate, essentially what that does, this turns elements in an array into a tuple so that you can see the index and the actual number value of the current value you're at. So our first value being 10, we know off the top of our minds that that's index 0 as well. So enumerate instantly knows to make I equal to 0 and then num equals to 10. So that's just an easy trick that, you know, having used Python before, I just know that. I don't know if that makes sense, but essentially the point I'm trying to make here is when you're doing problems, it's really helpful to actually have some sort of understanding of data structures and little tricks you can use in the specific language you're using, which is why I think Python's a powerful language to use for LeetCode, because there's so many tricks you can use to really simplify your code and your solution. And it's honestly kind of a flex. So I think it's a little bit impressive to the interviewer to actually know the little bells and whistles rather than just actual, just straightforward solutions to the problem you're trying to solve. If that makes sense. So, like I said, we're going to calculate the complement, which is going to be our target minus num, the value that we're at. And we're going to check to see, is complement in scene? Oh, I'm an idiot. It's not is, it's if. Know your if statements, people. That's what I get for talking out loud. Excuse me. So we know that if complements in scene, then we're going to just simply return the value of scene complement, which we know is going to be an index value, and then our index I that we're at. So in the example of, in our example of 10, 1, 25, we have, once we get to 5, we'll know that complement's already in scene, and we'll take the value of scene 1, which is going to be 1 as well, because that's the index value that's stored in that key value pair. And otherwise, we are going to add a new entry into the dictionary with the key being nums and the value being that index I. All right, let's give this a go. What did I screw up? Oh, this is important, guys. Okay, in the scope of an interview, in the actual scenario of being an interview, you're gonna have brain farts. When you're doing LeetCode, you're gonna have brain farts of the brain, like I'm having right now. Like, see, I try to pass in the entire list nums as a key instead of the current num that we're at. Okay, so now we're gonna give it a go. Accepted that. Let's just submit it, see what happens. Boom! Beat 100% of submissions. I'm the GOAT, essentially. And yeah, that's our solution to the problem. But let's talk about real quick the time and space complexity of our solution. Because again, this is very important. So our time complexity is going to be big O of n, because we're just iterating through the n length list of nums when we're doing all of our calculations. There's no inner for loops. The only thing that's happening essentially that's important, that's not in constant time, is the checking of each element in the array. Everything else, calculating the complement, checking if an element is in a dictionary, that's a constant calculation, and then inserting an element into a dictionary. Again, another constant calculation. So I guess it's like big O of n plus big O of 1 plus big O of 1 plus big O of 1, because of the 3 separate constant calculations. But since we only care about our worst case time complexity, we don't care about those linear calculations. We only care about the linear one, which is big O of n, not big O of 1. I might have mixed up linear and constant there. If I did, I apologize. First video, forgive me. And our space complexity is also big O of n, because we're obviously creating this new dictionary scene, which in the worst case could be the entire size of n, which is our length of nums. So yeah, we have that slight space drawback, but I would say in the grand scheme of things, having an n linear solution is much better than the original drunk guy solution of n squared. You could also do a 2-pointer solution to this problem, where you first sort the entire list from lowest to highest, and you have pointers from each end, and you make your way towards the middle of the array until you find the pair that you're looking for. But the problem with that is that solution has a time complexity of big O n log n, or even worse, because you have to, it depends. If your array is unsorted, you would have to first sort the array, which adds some time complexity to the whole solution. And then the act of going from the left and the right endpoint of the array and making your way closer and closer to the middle, that also takes time. And that again is a solution that like works, but like, why would you do that? Like, to me that solution is like, if you had a crush on someone and you wanted to slide into their DMs and you slid in their LinkedIn DMs, it's like, maybe that'll work. Sure, that's a way to solve the problem, but the best way is to hit them up some other way. Okay, you get what I'm trying to say. This is a bun solution. Again, don't make me pull up the steak cooking video again. Okay? Our best possible solution is using the hash map here, and that's the best way to come up with our $6 cover fee to get ourselves into the bar, dude. So to wrap things up, we have a couple different solutions you could use to solve this problem. Typically when you're doing LeetCode problems, there isn't one right answer. There are better solutions than other ones, and we saw this here today. We had the first drunk guy brute solution where you're checking every single pair, going through the list twice essentially, which is n squared complexity, which is trash. Do not do that. It works, but that's horrible. You can do much better than that always. And then we had our hash map solution, which was optimal. We had big O of n time, and sure, we had a big O of n space complexity, but that slight drawback for a better time complexity is the optimal route in my opinion. Then we had the solution of the you could sort the list and then use 2 pointers, which works, but again, why? Like, that's just, it's not the best solution. That seems like a lot of extra legwork just to get to the same solution that our optimal hash map solution gives us. All right, that's gonna wrap up today's video. Thank you guys so much for watching. If there are any problems that you want me to solve on here, leave them in the comments. Let me know a link or the name of the problem. If there are any experiences with bouncers you'd like to share based on the scenario here, let me know. Don't forget to, all that generic YouTube stuff, like a comment. You can like a comment, but also like the video, leave a comment, share this video. Thank you guys so much for taking the time to watch this. I love you guys. I appreciate you, and I'll see you in the next one. All right, peace.